Hi there, welcome to our Chapter 9 review. We are talking about claim testing here and those significance tests, those hypothesis tests. So let's dive on in. Tacos are awesome, read the content. Here's that information, timer, pause, and here we go. So with this question, it's there is no A, B, C, and D, so this is just the screen. Cool. So solutions are coming next. Anne reads that the average price of regular gas in her state is $4.06 per gallon. To see if the average price of gas is different in her city, she selects 10 gas stations at random and records the price per gallon for regular gas at each station. The data, along with the sample mean and standard deviation, are listed in the table below. Do the data provide convincing evidence that the average price of gas in Ann City is different from $4.06 per gallon, from $4.06 per gallon? So, first thing we got to do, well, there's the question. First thing we got to do is state, right? Oh, excuse me. So, because they didn't tell us anything else, we get to assume our alpha level is 0.05. What else? We want to recognize the mean value right there is $4.06. And what else should we know to do our state? That's about it. That's all we really need to know. We need to know what mu represents, and mu is going to represent the true mean value of the price per gallon in Ann's town, right? In Ann's town. Okay, terrible writing, but let's see that statement for ourselves. So we want to test the following hypothesis at the alpha level of 0.05, or I want to perform a significance test at 0.05, and my null hypothesis is that mu is equal to 4.06. My alternate is that mu does not equal, not that it's greater or less than, it just simply does not. And because it's a does not, that means I got a tail. So I'll talk about that in just a little bit. But mu is representative of the true mean price per gallon of regular gas in Ann City in dollars. So next after state is plan. If you need practice on state, here's your con. Plan. The conditions we got to check. Okay, so we've got random, and they said it, so I would quote back that wherever they said it, somewhere in here. Oh, I think I cut out some information, right? But so you just state back that it was random. Found it. Okay, state back that it was random. 10%, so we can make an assumption that 10 times 10 is 100, and that 100 is less than the total number of gas stations in Ann City. And finally, okay, well, our large counts rule, we don't have enough information to talk about that because we're dealing with means, we're dealing with these 10 gas stations. So instead, we've got to graph our data. So we take those 10 information, we graph it. You can use all sorts of online graphing programs. These are from the TI, but we notice there are no crazy skews, no outliers, nothing like that. And then look at that LSR. So it's just really nice and even on in there, nice, strong, positive linear line. So we're good to go. It's pretty normal. So we're good to go for all of our conditions. Here's a slide. You can pause and read through this a little bit slower at your own pace. Finally, we've got plan, practice for con. Finally, we've got do, the most important step, right? The math behind it. So I'm going to just go ahead and showcase so that the math can appear, and we'll talk about a couple of things one at a time. But Miles is here to remind me from Sonic the Hedgehog. He's here to remind me that we're dealing with two tails. So as we do our do, we've got to make sure that we remember that it's two-tailed at the end. So the test statistic is T, right? Because when we did our plan, we stated that it was a one sample T test. And if I forgot to say it out loud, I should have, that we stated it was a one sample T test for mu. So we're going to go ahead and do that T statistic because that is what we do. So we get our T statistic. Again, our standard deviation, our error is going to come from this formula right here of that population error divided by the square root of my sample size. Same formula we typically use. And I end up with this T statistic. So how do I go from here once we do this, if we're doing this all by hand? Well, the next step is to go to that T table. And I know that I'm using degrees of freedom of 9 because our degrees of freedom for T test statistics for one sample testing for mu is n minus 1. So 10 minus 1 is 9. So we look at the 9 and we try to find the values closest to 1.31. Because it's a T statistic, a two-tail, We also know that we're dealing with positive 1.31 and negative 1.31 because we are just not equal to, right? So we know we're dealing with both of those sides. So anyway, coming over here, I see that 1.31 is between these two values. So between 0.15, or sorry, 0.15 and 0.10. So I know both of these little tails are between 0.10 and 0.15. And because of that, I'm going to end up doubling them, right? Because I'm dealing with both sides of my proportion. So 2 times 0.10 and 2 times 0.15, I actually end up with a p-value between 0.20 and 0.30. So that would be a correct response. My p-value is between 0.20 and 0.30, or you could just split the diff and call your p-value approximately 0.25, or you can make some estimations based off of this number. I've seen some kids who are like, I think it's about 0.29, whatever. You can make some estimations. And finally, the last thing you could do before we move to that conclusion step is you could have used a calculator. With your TI Nspire, you perform a t-test with, if you don't have a TI Nspire or TI-84, you can go to social science statistics, so socscistatistics.com. This will be in that document I send out that deals with all of our online resources. But here, plug it all in. We got a p-value of 0.222644, and it is not significant, but we will get into that as we move to our conclusion sentence. So that do involve two different things, a test statistic, so that's this one, and our next slide would be the p-value. So two different cons going on again here. Finally, our conclusion. So since 0.2242 or 2.2246 or whatever my number was is greater than the alpha 0.05, we end up failing to reject the null. There is not convincing evidence that the true mean price per gallon of regular gas in Ant City is different than $4.06. And that's all we got. So here's a little practice on concluding sentences. And if you'd like to challenge yourself further, it's not required. You could do that unit exam. Moving on to our assignment, you can move through the PDF, do some questions from there, or you can go directly to the assignment, you doing the practice exam, multiple choices, FRQs, or do the cons. See you guys next week.